Good day, friends. Today we are going to talk again about conic sections. We had a look at their models and tried to understand what they look like and how they are formed. Now we are going to construct them. Not with rigorous mathematics, but using the properties of these conics, we'll have a string construction for all the four. Let's see how. The main property that we are going to use is about any point on the conic and its distance from the focus. That will be the main thing. We shall generally call a point on our curve as P. If there is one focus, we will call F as in parabola. If there are two foci, we shall call them F dash and F. This will be the common naming system. Now, for example, for the circle, we know that the property of a circle is that given a fixed point and a fixed length, all points which are at the same distance, they form a circle, or that is our circle. So what we can do is we can use a compass and draw like this so that all these are equal, or we can take a string and fix it here and move it, and that will give us a circle, and the property is satisfied because this length is always the same and that is the distance from the given point. Well, okay, coming to an ellipse. Ellipse has two foci. So what we shall do is, the two foci we shall call, as we decided, F dash and F. So this is F dash and this is F, and at the two foci what we have done is we have fixed two pins, but we have not just pushed them all the way in, we have left some space inside so that we can have a string which will go between the paper and the pin. Now we have taken a loop. We took a string and formed a loop, not just any length. The length is precisely, this distance is always denoted by 2c, F dash F, the major axis of the ellipse. This is F dash, this is F, and this is any point P, and the major axis is this, and that is always called 2a. Now, the property of the ellipse is that the sum of its distance, take any point on the curve, say here, then take its distances from the two foci. The sum of these two distances is always constant. So we shall have Pf dash plus Pf is always constant, and that constant is not just any constant, it is always equal to 2a, the length of the major axis. Okay, we are using this property and going to construct an ellipse. One thing we have to be careful here is that in verifications we arrange, rearrange and verify the result, and that's it. Here we are constructing something, and in every mathematical construction you have to prove that what you have constructed is precisely what was asked for. So I may draw anything here and say that here is an ellipse. That won't do. I have to show that this is an ellipse, or it is an ellipse that you have asked for. Okay, so now what we do is, we take a thread, form a loop, and the length of this is 2a, this is 2c. So we take 2c, this is given to us, F dash and F. So we take F dash F plus something, and that something is going to be 2a. Now what we do is, one thing we have to remember in all these string constructions, we shall have to take a pencil, put it in along the string and draw. Now while we do this, we have to be careful about two things. One is that when you put this, the string should be tight. It should not be just like this and do anything like that. It should be tight. Secondly, the pen should be perpendicular to the plane of the paper. Not like this or like that while you are doing it. Okay, so now let's get started. We have taken a loop which is f dash f, that is 2c plus 2a. We may write it down. We have taken the length of the string, total length is 2c plus 2a, and 2c is nothing else but f dash f. Okay, so now most of the work is done. That was the understanding part. The drawing part is very easy. Hold the pen tight so that the thread is tight and the pen is perpendicular. And go all the way around. So that is the ellipse. I hope you can see it. That's the ellipse. The pencil is not too dark, but anyway. Now, as we just decided, we have to show that this is an ellipse. Okay, what we do is, we take any point, anywhere you like, and as we have decided, we shall call it P. And what are we supposed to do now? We are supposed to show that PF dash plus PF is constant, and that constant happens to be the length of the major axis. Now, see here, we have put the pen on the point that we have taken. We want PF dash plus PF. We don't know that, but we know the entire length. The entire length is L. So PF dash plus PF will be L minus F dash F. So PF dash plus PF, which we are looking for, will be equal to L minus F dash F. Directly from the construction. Now this will happen anywhere. Even if you take your P here, PF dash plus PF will be the length of the loop minus F dash F. And L minus F dash F is nothing else but 2A. So we have just shown that PF dash plus PF is constant. It is equal to 2A. Okay, that takes care of the ellipse. And now we go over to a parabola. Now in a parabola, before we go actually over to constructing it, in a parabola, this is called the directrix, this is the vertex V, and here is the focus F. The property of the parabola is that you take any point on the parabola, its distance from the focus will be the same as its distance from the directrix. If you call this M, PF will be equal to PM. Okay, suppose I take P here, this will be PF, this will be PM. Suppose I take P here, PF, PM. Every time the two should be equal. Okay, so now all set to go for the parabola. We are given the focus. At the focus, as before, we have put a pin. Once again, not all the way, so that the string can go through it. And here we have a string. A strip, and tied to the strip, we call this point S maybe, and this length is precisely this much. Now this is our directrix. This is our focus. What we shall do is, we shall of course put the string, but then we shall, in the ellipse we have simply to draw, nothing else, only the thread and the pen. Here the thread and the pen and drawing part is there of course, but we have to move this along the directrix, just slide it. And while sliding, take care of drawing, and it will draw a parabola. Okay, let us see now. what we have described, we just first of all I just put the thread inside and now I start from here. I have to keep this tight, always touching the strip that I have here, and the strip should be moving. And so as you can see, you may not be able to see this. I will draw a little darker. This is what we do. Now in order to get this second side, you have to move this on this side and you will get the second part of the parabola. Now we also want to show that this is precisely a parabola, and for that purpose look at the construction. We take any point P here, say, and then we had this point like this. Now when we take this point, we want to show that PF is equal to PM. This is F. This is the distance from the directrix. We want to show that this is equal to that. Is it not obvious? The total length of the string is all this, and this has been taken away here. This much has been taken away and placed there, so these two have got to be equal. So PF is equal to PM, and that convinces us that this is a parabola. Okay, and now over to hyperbola. Now hyperbola has two foci, so we shall use the same sheet here. The two foci are F dash and F, and that is the part that it has common with the ellipse. The part that it has common with the parabola is that we are going to use a strip and move it. So once again we have to be careful now. Now we have taken a strip here, and this is extra thread. We are concerned with the thread from here to here. This is our point. Say, I'll draw the figure first. This is the hyperbola. This is one vertex V dash. This is the other vertex V, and this length is 2A. Now along this, which is the axis, we have the focus F and the focus F dash. And P is any point either here or here, anywhere on the hyperbola. You know hyperbola has two branches. Now the property that we are going to use here is again the distance of any point from the two foci. Ellipse we took the sum. Here we take the difference. So we take PF dash minus PF. There is a little problem when we come across minus. If P is here, PF dash is bigger. But if P is here, PF will be bigger. Okay, we'll take the modulus. And this is always constant. That is the property that we are going to use. And this constant is precisely equal to 2A, the distance between the two vertices. Okay, using this we want to construct a hyperbola. Once again we have a strip. We have taken a thread. The thread is smaller than the strip, and in fact if we call this length L, the whole length L is, this is say S and this is F, going to be F dash. Now this is going to be f dash, one end of the strip. The end of the loop will be fixed here. We have fixed one end at the focus, end of the strip, and the thread has been tied with the strip, and the other end of the string is here, and as in case of ellipse, it goes round the pin and between the board. Now what we have to do is, of course, as before, keep this tight here, but there we were sliding like this. Now we have kept this a little loose. We have to slide this like that around this focus. Okay, so now what we do is, here is the string. That is what we get. I will draw it in dark. Both in parabola and hyperbola, we have to take care of the strip, moving strip, as well as the string and drawing it. So sometimes there may be a little bit of shaky figure, but otherwise this is the figure. And now this is the hyperbola. We could take it here also, then it will be the entire branch. When we take this thread here and the strip here, we will get the other branch. So that is how we draw the hyperbola. Okay, now the question is this, how do you agree that if this is the point P on the hyperbola, we must be able to show that PF dash minus PF is constant. Okay, let us try. Now let us see. This was a point on our hyperbola. This was a point on our hyperbola. Now this total length is L, the string. So this much part has been taken away. Had we not put it here, the string would have come somewhere here. The string would have come up to here somewhere, and this would have been L. But what we have taken is, I don't know whether I mentioned it, but the length of the string, what we shall do is, we shall take it, if we call this point S, SF dash, that means from here to here, minus 2A. 2A is this. This is the length of the string that we have taken. Now we are trying to show that this is a hyperbola. We take a point here. Now when we take a point here, this is L. Now had we not taken it here, as in case of parabola, it would have gone all the way up to here. So this would have been L. Then this would have been 2A. Now this is, how much is this? PF. This is PF. And this is PF dash. So PF dash minus PF is this much, and that is precisely our length minus SF dash minus SF dash minus the length, and that is 2A. So that is how we show that this is precisely a hyperbola. Now just one word, and that is that in all these cases we have taken F dash and F. You may be given an equation where you have A, B and C, or just A as in case of parabola. Then what we have got to do, we have used A. We have used F dash and F as given, that means 2C is given. But suppose you are given A and B, there are relations depending upon the conic between A, B, C. From A and B we can find out C, or from B and C we can find out A, and so on. And then once we know A and C, everything can be done. Well, okay, thank you.